teleground bus should indeed be connected to the building's electrical ground and the building's steel within the telecommunications closet. This dual connection serves a critical purpose in ensuring the safety and proper operation of telecommunications equipment. Firstly, connecting the teleground bus to the building's electrical ground provides a direct path for electrical faults or surges to safely dissipate to the earth. This is essential for protecting sensitive electronic equipment from damage due to overvoltage conditions. The building's electrical ground, typically established through a grounding electrode system such as ground rods or a grounding grid, provides a low impedance path for fault currents. By connecting the teleground bus to this system, any electrical surge that enters the telecommunications system can be quickly diverted to ground, preventing it from reaching and damaging equipment. Secondly, connecting the teleground bus to building steel provides an additional layer of grounding and bonding. Building steel, when properly grounded, acts as a large conductive plane that can help to equalize potential differences within the telecommunications closet. This is important because potential differences between different pieces of equipment or between equipment and the building structure can lead to electrical noise, interference, and even equipment damage. By bonding the teleground bus to building steel, these potential differences are minimized, creating a more stable and reliable electrical environment for telecommunications equipment. The specific methods for connecting the teleground bus to the building's electrical ground and to building steel will vary depending on local electrical codes and industry best practices. However, some general guidelines should be followed. For connecting to the building's electrical ground, a dedicated grounding conductor should be used. This conductor should be sized appropriately for the anticipated fault currents and should be connected to the building's grounding electrode system at a suitable location. The connection should be made using a listed grounding connector that is designed for the purpose. For connecting to building steel, the teleground bus should be bonded to a readily accessible structural steel member. The connection should be made using a listed bonding connector that is designed for the purpose. The surface of the steel member should be cleaned of any paint, rust, or other non-conductive coatings before making the connection. In addition to these direct connections, it is also important to ensure that all telecommunications equipment within the closet is properly bonded to the teleground bus. This can be achieved by using bonding jumpers to connect the equipment chassis to the ground bus. The bonding jumpers should be sized appropriately for the equipment and should be installed in accordance with the manufacturer's instructions. It is also important to consider the grounding and bonding of any cable shields or metallic conduits that enter the telecommunications closet. These shields and conduits should be bonded to the teleground bus at the point of entry to prevent them from carrying unwanted electrical noise or serving as a path for fault currents. Regular inspection and maintenance of the grounding and bonding system is essential to ensure its continued effectiveness. Connections should be checked for tightness and corrosion, and any damaged or deteriorated component should be replaced promptly. It is also important to verify the continuity of the grounding system using a ground resistance tester to ensure that it is providing a low impedance path to ground. In summary, connecting a teleground bus to both the building's electrical ground and to building steel is a critical step in protecting telecommunications equipment from electrical surges and ensuring a stable and reliable electrical environment. By following industry best practices and local electrical codes, it is possible to create a robust grounding system that will provide years of trouble-free service. The National Electrical Code, or NEC, provides guidelines for grounding and bonding in telecommunications systems. It is essential to consult the NEC and any applicable local codes to ensure compliance with all requirements. Some specific sections of the NEC that are relevant to telecommunications grounding include Article 800, which covers communications circuits, and Article 250, which covers grounding and bonding. The NEC requires that telecommunications systems be grounded in accordance with specific requirements depending on the type of system and the location. The code also specifies the size and type of grounding conductors that must be used. In addition to the NEC, there are also a number of industry standards that provide guidance on telecommunications grounding. These standards, such as those published by the Telecommunications Industry Association, or TIA, and the Building Industry Consulting Service International, or BICSI, provide detailed recommendations for grounding and bonding practices. These standards are based on years of experience and research and are designed to ensure the safety and reliability of telecommunications systems. It is important to note that grounding and bonding are not the same thing. Grounding is the process of connecting a system or piece of equipment to the earth, while bonding is the process of connecting two or more conductive objects together to equalize their potential. Both grounding and bonding are essential for creating a safe and reliable electrical environment. In a telecommunications closet, grounding is typically achieved by connecting the teleground bus to the building's electrical ground, while bonding is achieved by connecting the teleground bus to building steel and by bonding all equipment, chassis, and cable shields to the ground bus. The combination of grounding and bonding helps to minimize potential differences and provide a low impedance path for fault currents. When designing and installing a telecommunications grounding system, it is important to consider the following factors. Firstly, the size and type of telecommunications equipment that will be installed in the closet. Secondly, the electrical characteristics of the building, including the grounding electrode system and the available fault current. Thirdly, the local electrical codes and industry standards that apply to telecommunications grounding. Fourthly, the environmental conditions in the closet, such as temperature and humidity, which can affect the performance of grounding connections. Fifthly, the need for future expansion and upgrades to the telecommunications system. By carefully considering these factors, it is possible to design and install a grounding system that will meet the current and future needs of the telecommunications system. It is also important to document the grounding system, including the location of all grounding connections and the size and type of grounding conductors. This documentation will be helpful for future maintenance and troubleshooting. In addition to the technical aspects of telecommunications grounding, it is also important to consider the safety aspect. Electrical shock is a serious hazard, and it is important to take precautions to prevent it. Firstly, always disconnect power to equipment before working on it. Secondly, use appropriate personal protective equipment, such as insulated gloves and safety glasses. Thirdly, never work on electrical equipment in wet or damp conditions. Fourthly, follow all safety procedures and guidelines. By following these safety precautions, it is possible to minimize the risk of electrical shock. Furthermore, the resistance between the telecommunications ground bus and the building's grounding electrode system should be measured periodically. A high resistance indicates a problem with the grounding system, such as a loose connection or a corroded conductor. Any problems should be corrected promptly to ensure the continued effectiveness of the grounding system. It is also important to ensure that the telecommunications closet is properly ventilated to prevent the buildup of heat and moisture, which can damage equipment and compromise the grounding system. The closet should be kept clean and free of debris, and any water leak should be repaired promptly. Moreover, surge protection devices, or SPDs, should be installed to protect telecommunications equipment from voltage surges caused by lightning or other electrical disturbances. SPD are designed to divert surge currents to ground, preventing them from reaching and damaging equipment. SPD should be installed at the point of entry of telecommunications cables into the building and at the equipment in the telecommunications closet. The SPD should be properly grounded to the teleground bus. The selection of SPD should be based on the voltage and current requirements of the telecommunications equipment and the anticipated surge levels. The SPD should be regularly inspected and tested to ensure that they are functioning properly. Replacement of SPD after a significant surge event is also recommended. In addition to grounding and surge protection, proper cable management is also important in a telecommunications closet. Cables should be neatly organized and labeled to prevent accidental disconnections and to facilitate troubleshooting. Cable trays or ladders should be used to support cables and to keep them off the floor. The bend radius of cables should be maintained to prevent damage to the cables. The telecommunications closet should be adequately lit to provide a safe and comfortable working environment. The lighting should be energy efficient and should be controlled by a switch or occupancy sensor. Emergency lighting should be provided in case of a power outage. The telecommunications closet should be secured to prevent unauthorized access. The door to the closet should be equipped with a lock, and access should be restricted to authorized personnel only. An alarm system should be installed to detect unauthorized entry. The telecommunications closet should be regularly inspected to ensure that it is in good condition and that all equipment is functioning properly. Any problems should be corrected promptly. A maintenance schedule should be established to ensure that all necessary maintenance tasks are performed on a regular basis. The maintenance schedule should include tasks such as cleaning the closet, inspecting grounding connections, testing surge protection devices, and inspecting cables. The telecommunications closet should be designed to accommodate future growth and expansion. Sufficient space should be provided for additional equipment, and cable pathways should be designed to allow for easy installation of new cables. The power and cooling system should be designed to handle the additional load of future equipment. The telecommunications closet should be located in a dry and well-ventilated area. It should not be located near sources of heat, moisture, or dust. The closet should be protected from physical damage. The walls, floor, and ceiling of the closet should be constructed of fire-resistant materials. The closet should be equipped with a fire extinguisher. The fire extinguisher should be readily accessible and should be of the appropriate type for the hazards in the closet. The telecommunications closet should be inspected regularly for fire hazards. Any fire hazards should be corrected promptly. In conclusion, proper grounding and bonding are essential for the safe and reliable operation of telecommunications systems. By following industry best practices and local electrical codes, it is possible to create a robust grounding system that will protect telecommunications equipment from electrical surges and ensure a stable and reliable electrical environment. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Remember to consult with a qualified electrician or telecommunications engineer to ensure that your grounding system is properly designed and installed. It is important to remember that electrical codes and standards can vary depending on the jurisdiction. Always consult with local authorities to ensure compliance with all applicable requirements. Proper grounding and bonding are crucial for the safety of personnel and the reliable operation of telecommunications equipment. Neglecting these aspects can lead to equipment damage, data loss, and even electrical shock hazards. Investing in a well-designed and properly installed grounding system is a worthwhile investment that will pay dividends in the long run.